Vanakkam. Hello everybody. Today we are going to solve a problem from GATE EC 2021 question paper. The question number is 19. The circuit is given here and we are asked to find V0, which is rounded off to one decimal place. Okay, let's get started. We start analyzing this circuit first. We are going to use mesh analysis method to solve this problem. There are three loops like this. This is loop 1, this is loop 2, this is loop 3 with the mesh currents I1, I2 and I3 respectively. Hence, there are three unknowns. We can write them as I1, I2 and I3. These are the mesh current as well as these are the unknowns. Since we have three loops, we can make three equations. We can write down three equations. But as we have two number of current sources like this, as the current sources 2 milliamps and 6 milliamps are located in the peripherals or the circuits, we need only one KVL for loop number 1 alone. The remaining two contains I values directly. So this makes the solution simple. Okay, now we move on to write the KVL for loop 1. Start from this bottom leftmost corner. We traverse through this path. So at that time we can write the equation like this. 1 into 10 power 3. This is for this 1 kilo ohm. So that resistance multiplied by the current which is flowing through that one is I1. Then so we go through this minus first so that we can write it as minus 4 volts. Then we traverse through this path in which no element is available, and then we travel through this path in which we have 1 kilo ohm resistance available, and the voltage is given as plus V0 because we come across this plus initially. So this is plus V0. Then through this path we don't have any element and it ends here, so that it can be written as it is equal to 0. Now in place of V0, and for this V0 we can apply Ohm's law. So what is Ohm's law? We know that Ohm's law is V is equal to I into R, isn't it? So for this V0, the I value is difference of the currents I1 and the I3, because this 1 kilo ohm resistance is common for both the loops, this first loop and the second loop, through which this I1 and the I3 currents are flowing. So we can write the difference of this current multiplied by this resistance value. So it is nothing but 1 kilo ohm. So 1 into 10 power 3. This thing can be substituted in this V0. So it is 1 into 10 power 3 I1 minus 4 plus I1 minus I3 multiplied by 1 into 10 power 3. I write it as 10 power 3, that is equal to 0. So it can be written as 10 power 3 I1 minus 4. By expanding this, we can write this as 10 power 3 I1 again minus 10 power 3 I3, that is equal to 0. So by combining these two, we get 2 into 10 power 3 I1, isn't it? So 2 into 10 power 3 I1. Then I write this 10 power 3 I3 with the minus sign. And then I am bringing this minus 4 to this side so that it becomes plus 4. So this is equation number 1. So when you refer this loop 2, there is no need to write this KVL and all, because we have the current source which is available at the peripheral, so that we'll get the current value directly, the unknown value directly. So this I2 is equal to minus 6 milliamps. Why we put minus sign here? This is because this I2 current is flowing in this direction. At that time, the current source value 6 milliamps is flowing in the opposite direction. So that we are putting this minus sign. This is equation number 2, or actually we get the answer here. This is first answer for us. Then we move on to loop number 3. So in loop number 3 also we need not apply this KVL, because this current source 2 milliamps is available at the peripheral of the circuit. So that we'll get the direct answer for the I3 current. That is, the I3 current and the current from the 2 milliamps current source are flowing in the same direction. Both are flowing in the same direction. That's why we get the positive value here. This can be taken as equation number 3, as well as this is the second answer for us. So now you come to this equation number 1, in which we can substitute this value of I3 as 2 milliamps, so that I can write this as 2 into 10 power 3 I1 minus 10 power 3 into, instead of I3 I can write it as 2 into 10 power minus 3, because we have milliamps here, that is equal to 4. So So this is the modified form of this first equation. From here we can get the I1 value. So it is 2 into 10 power 3 I1 minus 2 into these two get cancelled. So minus 2, that is equal to 4. Then 2 into 10 power 3 I1, that is equal to 4 plus 2 when you bring this 2 to this side. So 2 into 10 power 3 I1 is equal to 6. So I1 is equal to 6 divided by 2 into 10 power 3. So that we get this value I1 as 3 milliamps. So this is another answer we get, third answer. But the question in this problem is to find out V naught, isn't it? So this V naught is nothing but the current flowing through that one multiplied by the resistance. So we have the difference of the current I1 minus I3 multiplied by I1 minus I3 multiplied by that 1 kilo ohm. So it is 1 into 10 power 3. So here I1 value is 3 milliamps, 3 into 10 power minus 3 minus I3 value is 2 milliamps, 2 into 10 power minus 3 multiplied by this 10 power 3. So it is 3 minus 2 into 10 power minus 3 when you take this minus 3 outside. So into 10 power 3. So these two get cancelled. So we get the value as 1 volt. So this is our answer, required answer. Thank you.